Hello everybody, I am Dr. Munir Mahdi. Assalamu alaikum. In this video I'm going to show you how can we create structure modeling. It is just a quick review about creating structure modeling by using Petrel. I'm not going to discuss in details the workflow for structure modeling, but just a quick review about the main steps in creating structure modeling. In this data, we have a false set of faults, major faults and minor faults, and a set of horizons. I'm not going to work or create structure modeling along all of these faults because it's going to take too much time. So I'm going to select maybe the first 9 faults in order to create our structure modeling. Let's start with structure modeling. I prefer to start with structure framework. In structure framework, I have to select to choose a name for the structure framework and select either it is a time domain or depth domain. This data is in a time domain, so I'm going to select time domain and OK. Now I created the structure framework in time domain. The next step is to create the fault framework from the interpreted faults. So I clicked on the fault framework. I select the required faults, maybe from M1 to M9. So I added here 9 faults, yes, and then select each fault as an input data. Now I added the seismic interpretation, the interpretation as an input for the fault framework. This is settings or parameters that enhancement the appearance of the faults, either the resolution, the smoothing, the tip loop, the extrapolation, and the fault top. In case that there is a top for the fault along our wells, I have to add this top in the fault framework just in order to be taken into consideration while creating our faults. These settings is similar to these settings, but if I'm going to add or apply any correction or any update or to change any of this of the parameter of this setting, it's going to be applied along all faults directly. It's not required to select each fault to apply this correction or this update. Just click on the update here and it's going to be applied to all faults. Now I'm going to click OK, remove the data, and now the Petrel created my faults. This is called the fault framework, or in corner point grading it's called fault model. Now I have a fault framework or fault model for my faults. Returning back to the fault framework, I'm going. The Petrel are going to show me the relationship between intersected or connected faults. The relationship between intersected or connected faults. According to the Petrel, the software considered M5 as a minor fault and M9 as a major fault, and asked me to determine or define the kind of truncation between M5 and M9. As I selected, or as the software considered M5 as a minor fault and M9 as a major fault, the software are going to delete either above the fault or below the fault. The software going to delete the minor fault. So he is going to fix it M9. There is nothing are going to be added or removed from M9, and the software are going to delete or add M5 either above M9 or below M9. Let's have an idea, or let's have a look along the software, along the faults. I just need to remove these faults and just show M5 and M9. That's M5 and M9, and they connected at some point here. Yes, there is a connection here at some point, okay? The software considered M5 as a minor fault and M9 as a major fault. I think it would be better if you change the colors. M5 maybe red. Apply. Yes, Now we have M5, this is the minor fault according to Petrel, and M9, this is the major fault according to Petrel, and there is a connection here between two faults. There is a connection here between the two faults. So if I selected to be above and select apply, below, select apply. I don't know why the software didn't work on or delete this data. Okay, let's try in M8. Ah, here it is. Okay. In the second connection between M8 and M9, also I would like to change the color of the M8. Maybe yellow. Apply. Okay, that's great. The fault framework or the Petrel consider M8 as a major fault and M9 as a minor fault. Once I selected that the truncation be above M8, so the software deleted all M9 and just leave this part of M9 fault and removed the other part of the M9 fault. So if I'm going to select below, apply, the software removed this part from the M9 fault and keep this part of the M9 fault. Okay. So in the fault relationship, in the fault framework controls the connection or the truncation between faults in order to enhancement the appearance of our structural model. Once I created the faults by fault framework, I'm going to convert directly the fault framework from the structure framework to the corner pointing grading. So I'm going to click on structure framework to fault model, select a name for the new fault model by corner pointing grading. I will keep this name as it is, and then added the faults. Now I added the fault framework, and I'm going to control the distance between pillars. Let's show the pillars without controlling the distance between pillars, and then repeat it again by increasing the distance between pillars or the spacing between pillars. That's great. Now I created my new model by corner point grading, including the faults pillars. This is the faults pillars, but the faults composed of huge number of pillars, large number of pillars. I need to decrease these pillars in order to be easy to control the faults or to control enhancement my faults. So I am going to increase the pillar spacing rather than 100, maybe 500. 500 is a good number of pillars, maybe increase little to 700. That's perfect. I think this is a very good number of pillars for each fault. Now I can control these pillars or enhancement these pillars, the faults, easily with a suitable amount of pillars. Okay, now I have my corner point grading. I have my fault pillars and I can control these faults. The first step in order to enhance these faults is to extend the faults or cut the faults until the faults have the same length. I need all faults to have the same length. I do not need any faults that have different lengths. I do not need the faults to have different lengths. I need all faults to have the same length along my model. So I'm going to open fault model operation. In the fault model operation, I'm going to select the top limit and the bottom base limit, and I'm going to make it constant. Constant means that I'm going to add a number, a depth number for the top of the faults and the depth number for the base of the faults, for each fault. Okay. How can I select these numbers? It's from the horizons or the maps that I'm going to add in the model. If I have a look here, I have base Cretaceous, upper Jurassic 1, upper Jurassic 2, middle Jurassic 1, middle Jurassic 2, top lower Jurassic, top Triassic. So the upper formation, the upper horizon is the base Cretaceous. So I'm going to open the setting. and have a look on the elevation time. The elevation time started from negative 2184 till negative 1491. This is the shallowest depth in my map-based Cretaceous. So I'm going to be shallower than the shallowest depth in the Cretaceous map. So I'm going to select negative 1400 is a suitable number for the top of the for the top limit of my folds. So what about the base? If I'm going to create my model only based on the base Cretaceous, so I'm going to select depths deeper than this length. I'm going to select depth deeper than this length, but I'm not going to select the base Cretaceous as a base for. I'm not going to create my model only based on the base Cretaceous, so I have to select another horizon, top Triassic. I'm going to. I need a model that covers base Cretaceous till top Triassic, so I'm going to open the setting of the top Triassic and open the statistics of this formation or this horizon. It ranges from negative 3092 to negative 2142. So I'm going to be deeper than the deepest point of this horizon. So I need negative 3100. Yes, 3100 is a good this depth. Now I'm going to click on cut and extend. Perfect. Now I have all folds have the same length starting from the same point and ending with the same point. Okay. The next step is the next step is to enhancement the appearance of the folds, enhancement the smoothing of the folds, the length between pillars, the spacing or distance between pillars, and remove any connection or fix any connection between folds and fix any truncation between folds. This is a very easy step. I'm just going to select the fold in the 2D window and then select the 3D window. I'm going to click Photo Model and I have here smoothing and equal space. First, I have to click on the equal space, then I click on the smoothing in order to enhancement the appearance of the folds. Do not click smoothing too much in order to not over smooth the folds or change the location or the position of the folds, because changing the position of the folds controls the area of the hydrocarbon or the areas that you are going to use for your hydrocarbon calculation or volumetric calculation. Either be larger than the actual area or smaller than the actual area. So do not apply too much smoothing along your folds, just in enhancement of the visualization of your folds. Equal space and smoothing, equal space and smoothing, equal space and smoothing, equal space and smoothing, equal space and smoothing. Okay, perfect. Now I enhanced the appearance of all folds. It's required to remove the connection between folds or fixes the connection between folds. This is not the target of our course now, so I'm not going to discuss it deeply, just to save time and effort. The next step is to create the polygon in order to create the boundary of the model. So I'm going to click on seismic, polygon editing, new polygon, and I prefer to select make rectangle. Just click on create 3 points and the rectangle are going to be created. If I need to enhance the points of this polygon or the area of this polygon, I can select on edit polygon and move the points to the borders or the boundaries that I need. and now I have my own polygon. This polygon is not the model boundary till now. I'm going to convert this polygon to a model boundary so I can use it during my structure modeling. Right click on the polygon and click convert to grid boundary. Convert to grid boundary. Now I have my grid boundary. This is my grid boundary. This is my grid boundary. Now this is the boundary of my model. Okay. Next step is to define the direction of the faults. Define the trend of the faults. Either in I direction, east west, or in J direction, north south, or in arbitrary direction. Okay. In order to save time and effort, also I'm not going to select it manually or define the direction of the faults manually per fault. I just going to click on auto assignment. In auto assignment, the software define the direction or trends of the faults automatically based on the point of view of the software. If I'm not satisfied with one of his selections, I can change it to as I need to the required direction. Once I created the trend or defined the trend of each fault, I'm going to create the pillar grading. As I said, it's the I and J increment is 100 multiplied by 100. This is suitable increment for the simple geological model or for the first geological model. Maybe I decreased this number in order to increase the number of cells, but it depends on my requirements and depends on the reservoir engineer requirements. If the reservoir engineer need more cell or large number of cells, he is going to ask me to increase the number of cells in the grid, so it decrease the increment from 100 to maybe 50 or lower than 50. Okay, I need to select apply. As I said, you have to activate the 2D window in order to perform pillar grading step. If you do not activate the 2D window, the software are not going to accept to create the pillar grading. If you do not activate, you just are clicking on the 3D window and clicked apply, the software are not going to accept this step. He will going to ask you, please activate the 2D viewer, not the 3D viewer. So you have to activate the 2D viewer before creating your pillar grading and click apply. As we do not worked on the connection between faults or in the intertruncation between faults, the software determines that there is a problem in the faults and it's going to create problem in the pillars. We are going to have distorted pillars due to the bad connection between faults. I'm going to accept this now, but it is just now because we have a quick review for the structure model. It's not a detailed discussion of the structure model. But if you are going to create your own structure model for your own work, it's not allowed, it's not suitable at all to keep these pillars or to keep this distortion in the pillars while modeling. You have to fix this distortion before creating your pillar. I'm going to select yes. There is another distortion or distortion cells. I'm going to select yes. Now the software created my mid skeleton or the skeleton or the cells of my model. I'm going to select OK. He asked me, are you going to create the top and the base skeleton? The software created only the middle skeleton. He asked me, do you need to create the top and the base skeleton? I'm going to say yes. Still have problems in the pillars, yes. Still have problems in the pillars, yes. Okay. Now the software created my grid with 3 skeleton. Top skeleton, mid skeleton, base skeleton. This top skeleton, mid skeleton, base skeleton. How can we define a perfect software or a perfect skeleton for our model? If the skeleton is flat like this is considered as perfect skeleton. But if we zoomed, there is a kind of distortion in these cells. all of this distorted cell is not suitable or is not uniform for reservoir engineering or property modeling. You have to fix the correlation between faults in order to remove all of this distortion. It's not applicable and it's not suitable at all to fill the cells with your property data while the cells have this distorted shape of the cells, or the cells characterized by this kind of distortion. We need the cells to be uniform like these cells. But the distorted cells, it's not applicable at all, and the software and the reservoir engineer are going to return the grid to you because it will not be helpful for flowing any dynamics, and of course it's not going to be helpful for filling these cells with your property numbers of property data. Okay, the next step is to create our horizons. I'm going to select horizons, return back to my horizons. I have 7 horizons, 1, 2, 3, 4, 5, 6, 7. So I created 7 horizons. Clicked on enable, disable multiple choices. And select the first one. Just add the first one, and all other horizons are going to be added directly. Okay, now we have the horizons, the interpreted horizons here. For the first step for creating make horizon, I prefer to create horizons without adding the well tops, just to make sure that there is no any distortions related to the seismic interpretation. So I'm going to click apply. Now I created my horizons. Let's check the horizons. Here I have here my horizons, base Cretaceous and top Triassic. It's good enough to select the upper one and the lower one. It's not required to select all of your horizons. Enhancement the colors. This is the color of my map. If I am satisfied with the elevation and the depth of this map, with the faults and the structure of the map, if I am satisfied with this view of the map or with the output of my model, I'm going to add my well tops. Adding my well tops is with exactly the same step of adding the horizons. I'm going to select the first well top, select on enable, disable multiple drop-in table, and clicked on input. Now the software select all the well tops to enhancement the interpretation by my well tops, and click apply. Okay, now I created my horizons conformable or confirmed with my well tops. In case that I'm going to add a new well or add a new top or update any changes or add any changes to my well top, to my current well tops, it's very easy step. Just I am going to Open well section window. Where's well section window? Here is my well section window. Add my wells. And add my well tops. Here is my well tops. Now I have these well tops. Okay. What if I need to add any well or to update any well top? Let's click on edit well tops. Yes. What if I need to change this well top or remove this well top or add a new well top? What if I need to add it add it anywhere? Just update, perform the updates that you need along any well top as you wish, as you need any update along the well top. Once you perform these updates, it's going to be recorded directly on the database of the well top in the synthetic well tops. It's going to be recorded directly here. If you're going to remove this well top, it's going to be recorded directly here. If you're going to add a new well and adding the well top, you are going to add the well top under the same name. So it's going to be recorded directly here. So it's not required to repeat any step. Just click on structure or modeling, horizons, and click apply again, and the software are going to choose the new updated well top along either the wells or the old wells or the new well. Once you created a new well and once you created a new top, or if you updated any changes along the old well top, it's going to be directly recorded along the same database. You just click apply and the software are going to use the new data that you updated or changed in updating your model. Okay? Okay. What if I need to add a new top that's in my wells and there is no any seismic interpretation for this top? What if I need to add new horizon? Insert horizon. What if I need to add this horizon? What if I need to create a new horizon in my wells and there is no any horizon interpretation or any data or any seismic interpretation for this horizon, just my well tops? What if I need to create a map for this horizon and there is no any seismic interpretation available for me? I need to create a map for horizon 1 and I do not have any seismic interpretation. Can I create a map for this horizon 1 based on the available data or based on the model, my model, without seismic interpretation? The answer is yes. How? It's very easy step. Just you have these horizons, you have your own model. Just click on zones. Click on zones. Once I clicked on zones, I am going to have here the location of my zone. Either the zone is above Cretaceous, between base Cretaceous and Upper Jurassic, between Upper Jurassic and Upper Jurassic 2, below Top Triassic. My new zone, my new horizon is below Top Triassic. And I'm going to click Add in the table, select conformable, and select the horizon. I'm sorry, below Top Triassic. Below Top Triassic. Just click on conformable and select my horizon. Okay. In this case, Petrel are going to add horizon 1 for me. And in horizon 1, now I have a new map for the new horizon, conformable with the upper horizon, conformable to the horizon above this zone, and based only on my well tops without seismic interpretation. It's not required to reinterpret any or to have an interpretation for this horizon. It's just enough to have the well tops and use the zones click or the zones button in order to create a map for this well top. Okay, layering is a mandatory step, but it's required. It's required for upscaling well log, or it's conformable with the upscaling well log. So I'm going to postpone talking about layering until we discuss the upscaling well log, and then I'm going to return back to layering step. Okay, now we created our model. We have faults, we have grid, we have horizons, we have zones. We need to QC this 3D geocellular grid. We need to QC the cells of our model in order to make sure that these cells is suitable to be sent to the reservoir engineer for dynamic flow, or is suitable for to be filled with my property data. First step is I'm going to select geometrical modeling and then choose in the method cell angle. Cell angle is the internal angle between the sides of each cell. So I'm going to select internal deviation angle. I need the maximum internal deviation angle because I need to know what is the maximum angle that I have, because I need to make this value as low as possible. As low as possible. There is no way to allow the internal angle of my cells to reach to 90 degree. It must be lower than 90 degree. Higher than 90 degree means obtuse angle, and obtuse angle is not suitable at all for any kind of population, either populating or distributing the values of my property, the lithology or fluid or petrophysical properties, or the value, the dynamic flow for the reservoir engineer. So I need to make sure that most of my cells, the internal angle of most of my cells is lower than 90 degrees. I'm going to select the three trends, IJ trend, IK trend, and JK trend. Start with IJ, and click apply. In properties, I will going to have cell angle internal maximum IJ. Cell angle internal maximum IJ. The second step is create new cell angle IK, apply, then create new cell angle maximum JK, apply. Okay. Okay. Now I remove all of this data and just select on the required property. Now this is the cell angle, internal cell angle, maximum value in IJ direction, and I need to enhance the global color table, maximum and minimum, and okay, and show the auto legend. Yes, this is auto legend. Okay, all the cells colored with blue, green, yellow is very good cells. I do not have any problem with the angle along these cells. But if we closed here, we were going to find cells with this gray color. Gray color means that I have either 90-degree cells or obtuse cells. If I have 90-degree cells, it's okay. It's not recommended, but it's okay. But if I have greater than 90 degree, this means that I have obtuse angle, which is not recommended at all. I have to fix the faults along this area, the relation between faults along this area, in order to fix the cells along this fault. And the same case in the IK direction, and the same case in the JK direction. Okay? Okay, the next step for the geometrical modeling is the cell inside out. Cell inside out means that if I have any crushed cell, any destroyed cell or destroyed cell, the perfect value for the cell inside out is 0. If I have a model with 0 cell inside out, it's okay. This is a very good model. If I have a value of I have cells for the cell inside out, I have to fix the connection or the false relationship along these cells in order to remove this cell inside out. As we can see, there is the maximum value is 9. which means that I have inside out cells. The blue color is a perfect color, but these colored cells, rather than blue color, I have to fix these cells. All of these cells is distorted cells. I have to fix these cells. And commonly, most of the distorted cells because of the presence of faults. So I have to fix the relationship of these faults, either the connection of the faults, the truncation of the faults, or the trending of the faults, in order to decrease these inside-out cells as possible. Okay? The last step for geometrical modeling is to estimate the volume of the cells. To estimate the volume of the cells, I have to make sure that I do not have any negative value for the volume of the cells. I do not have any negative volume for the cells. If I have a negative volume of the cells, it means that I have a problem in these cells. Okay? If we selected the statistics of the bulk volume, the maximum value for the volume is okay. The minimum value of the volume of the bulk volume have negative values. This negative value is not recommended to be available at all along my model. I have to fix the cells of the model in order to remove the negative value for the cell volume. This is a mandatory step before population of my properties or sending the grid to the reservoir engineer. Maybe it's not appeared along the surface of the model, but maybe inside the cells or inside the model. If we cut a cross section along our model like this, intersection, created intersection, new intersection, tools, east to west, clip behind, and open settings, transparency degree 90 degree, apply, okay, and I'm going to select this button. I'm sorry, I need edges, horizons, folds, bulk volume. Okay, as we can see here from the bulk volume colors, the blue color indicate negative volume. The blue color indicate negative value for the bulk volume. We have to remove this negative value of the bulk volume in order to enhancement my grid of my model. This is quick view or quick quick video about how to create structure modeling. It's not there are a lot of details that I didn't discuss in this video because structure modeling is not the main aim of this course. I'm just give an hint about quickly how can we create a draft copy of our structure modeling. Thank you for following, and if you have any questions, please do not hesitate to be in contact directly with me. Thank you. Assalamu alaikum.